Okay, so we are going to discuss Kolb's theory here. It's the learning theory, his reflective learning theory, and for experiential learning. And so basically what he says is that people learn best by doing. And so you do the experience, you experience the learning, then you reflect on it in your learning. And by reflecting on it, it allows you to become a better performer or to be able to reevaluate and learn better for next time, is what it is. That's the
Which
main
I
definition.
think really ties super well into science. So, we have our,
Mhm.
our scientific theory is not the same, but it has that kind of that similar guidelines. We really thought this would tie in very well with Kolb's, just kind of what we teach as well.
Yeah, it's very similar. I agree. Down to that observation, if for scientific method, if we're observing something, I feel like that's when we're experiencing it, and then we're reflecting on it, and then we're going, what's the next step?
Mm-hmm.
And that is very much into that Kolb cycle when it's asking what's the next, where do you go from here, kind of thing.
Yep, and taking those past experiences to then make things better, reevaluate your experiment or whatever it is that you're.
Yeah. And so I thought it was kind of interesting. So it just says learning is a cycle. And so we receive the information through concrete experience. So again, that's your experiment or what you're observing there. We're taking in those sights and sounds through our senses. So we're doing, we're seeing it, we're tasting it, we're smelling it, touching it, and then we're thinking on it. We're transforming it into our brains. We're kind of inputting it there. We're reflecting, and then we're going to transform it again as we access it and we change it and we go on to something else. So, and that's exactly what we do in science, right? We look at something, we run an experiment, we test our hypothesis, and then we evaluate it, we think on it, and then we either go back and reevaluate our hypothesis and come up with a new one or tweak it, or we see and we come up with another idea, basically.
Like that's exactly
or we say,
what I do
it
as a teacher. Did it work today? No. Well, why didn't it work? What piece went wrong and why, and how can I make it better for the next time? I think it's a cycle that we use, just in daily life. It's maybe not something that we technically define, but it's definitely something that we do in science and then in just learning in general. So kind of like bring it and it's like used in the classroom, kind of how we can bring it in. So this past year, we were supposed to adopt new science curriculum, but we had some issues with subs. And anyway, point being here is that we've really been looking a lot into standards, and really a lot of it has been based off of what they're calling modeling, and then in like biology, more the biology area, something that they call storylining. So there's something that's been around for a couple of years. I think there's a couple different companies that do it. They're called the Illinois storylines, and they really tie into this idea of learning new things and then reapplying them. So when you think about like the traditional methodology of us teaching science, we're going to present information to our students, they then learn from that, and then we give them like examples of that in nature. So the exact opposite of that with storylining, you're going to present a phenomenon or a problem or some thing they see in nature, and have your students, instead of directly giving you the information, you have them go out and research and trying to come to conclusions like why that is. So again, going through that experiential model, well, maybe I thought it was this and then I found out it wasn't. Well, now I think it might be this, kind of just continuously working through that cycle. So that's kind of biology specific. There's also one that they call modeling, which I just recently did a workshop on. This is really specific to physics, and I cannot lie, my brain really hurt by the time we were done. So I have a hard time visualizing it for freshmen, but just in general for like the topic of that process, modeling is very similar to that. They'll be presented with something like, what is velocity, or can we define velocity, and they sort of have to work backwards when they're given problems, and then we come to a definition and like, why would we call it that? It's a whole lot of group discussion, a whole lot of people pulling from prior experiences and kind of adding to that continuous cycle together as a group. But I can't lie, I cannot imagine my freshmen doing that. It was a group of teachers, and there were some spots where we were frustrated, and I was like, yeah, I can't, my freshmen would be using it. So
it sounds pretty advanced, but they say we learn best when we are frustrated, because we overcome.
And I think that a lot of times we don't give our students enough credit. I think a lot of times they're so used to just being given the information that it's really frustrating for them at first to be asked to do that. This past year, I did a couple of different POGIL activities, like process-oriented guided inquiry learning. But basically same thing. You kind of give them a worksheet / activity that you largely don't give them a whole lot of instructions on, and you kind of expect them to fail and work with each other. But what I found is our freshmen don't have a whole lot of adversity. And again, I think it's because we feed the information and don't really let them go through this cycle on their own. So I can see why this would be useful, especially in the science classroom, instead of just giving out, actually letting them be the scientists and come to the discoveries. But again, it's in theory, I find it very difficult with maturity levels, but who knows? Maybe
See, I think I've done something similar, more, I don't want to call it necessarily like, I don't know if it's necessarily Gibbs, but it's very similar to our scientific method. It was in the realm of project-based learning for STEAM class. And so what they did is we talked about, and ahead of time, we talked about the garbage patch in the Atlantic Ocean, right? And so I presented them with this problem, and then what they had to do is they had to, within their groups, figure out some solution to the problem, whether it was to try to build a cleanup machine, or they could some way come up with somehow to creatively recycle plastic back so it never hits the landfill in the first place. And so that was kind of neat, because all I did is I gave them it, we discussed the problem in general, and then I said, go. And they had such different ideas from each group. I did have one group build a flotation kind of hydraulic crane device to pick up plastic out of the ocean. And so they demonstrated it in like a little pool thing with picked up ping pong balls out of it, which I thought was really kind of cool. And then I had another group recycle Walmart bags. They actually made a hammock out of it. So they said we could process these, make a bunch of them, and everybody could have a plastic hammock, And then another group built sleeping mats, and they thought that would be a great solution. So not only could you use it if you were just out and about, but they thought maybe it was, they had done some research and they found out that people were actually making for homeless people.
I was just, that's very practical.
And then my artsy students, they made flower bouquets for all the teachers for Teacher Appreciation Week out of Walmart bags. So I was actually quite surprised at how they turned out. Walmart bags and Sprite bottles, of all things. So
I think that the whole aspect of the project-based learning, the inquiry-based learning, the modeling, all of the kind of things that we're talking about, it's all like making yourself as the instructor the facilitator instead of being the direct instructor, which I really struggle with. And I definitely see the, because like you would probably never would have expected those kids to come up with something as intuitive as that is, especially the bed mats. That's pretty genius, but and I think that's largely why this would be so useful for like the classroom setting. And I don't know if you wanted to kind of mention the constructivism and constructionism
that we were talking about before. Yeah, well, and I do want to go back and say part of what makes this great is because, like our Kolbs, they had to reflect on what they did. So they had to go back and analyze how could they have made it better. What aspects would they change about their project in the future? So how could they? So that had that reflective quality that went back to that. And again, like you were saying, the constructionism, it plays into it quite well as well, because constructionism, what you're doing is you are basically presented with a problem and you are actually building that solution. So you're, whether it be a plastic problem solution or designing something else to basically solve that problem that you're being presented with. And that's, it's the actual constructing of the model, or constructing, say the design, that's where they're coming up with their solutions at. And so I really like that. I think that fits STEAM really well, and it fits science as well. And then it gets all of these basically have collaboration as a part of them as well, which we all know we're not in a bubble.
Right. Well, when you say that, it makes me think of like the science models. You think of like the floating foam atom, or the half cut in half foam ball that's turned into a cell, and it does make me think of all of that. But it also makes me think of, have you ever used like foldables? Do you know what I'm talking about when I say those?
Yes.
So I use foldables quite often for my students, and I mean that while it's not technically, they're not creating anything super in depth, but it is, at least a physical aspect. It's something that they create. I even, for my lower level kiddos, we made, which I didn't know they were called these. I never knew that. They're called cootie catchers. The things that like open.
Oh, yeah.
and we put like terms inside of them. And of course, they lasted for all of 20 minutes, but it was still like a fun. So I mean, what I'm saying is it can extend to more than that. And then like another example is for gas laws, for Boyle's law, stuff like that, you can use a popsicle stick and put pressure and volume on, and then when one goes up, the other one goes down. So they can like physically see that relationship. And then like also making graphs, like maybe you're not constructing a model, but you're constructing a physical representation of data. So I think that extends a lot farther than just modeling and that kind of thing. I just want to throw that in there. So I feel like we do a lot of this stuff without realizing that we just never really put a term on it. Like I do a lot of constructionism in my class.
I always thought we're just doing hands-on science.
But
we're just doing hands-on science, right? Like that's how it's supposed to be. No, I get it. Have you done the balloon lab with the beaker to illustrate gas laws?
No.
Where you heat up so I let the kids do it this year, and you put the balloon over the beaker, you have a little bit of water in, and you boil it up, and basically the air heats up, it expands, right?
Yeah.
And so it blows up the balloon, and then you take it off the hot plate or your Bunsen burner, whatever you have, and then you can actually watch it deflate as it cools down. So that was kind of cool.
So
and then there was
I had tried to do something similar with plungers where you like put a set amount and then you burn the tip of the plunger. So it's like a vacuum, and then you put one in cold water and one in hot water, and it just doesn't work very well. I think the plungers were too strong, and I ended up scrapping it because I did mini stations, and it was just requiring too much of me to be there. But that sounds like way easier to demonstrate.
There's another one if you want. It's
myself.
Oh, it's okay. You put water in it like a Coca-Cola can, and I hoard cans.
Oh, that one I've done, the one where you flip it.
Yeah, where you flip it and you get it.
Okay, that was one of them, and that was probably their favorite station. And then I did one with. Have you ever heard of Cartesian divers? You put a little dropper of colored. You just like use some colored food coloring. I did blue because we're Goddard and it's our colors. Anyway, I just put a little bit inside of a little dropper, and then you put the dropper inside of a bottle of water. I use the Smart Waters. They work best. Anyway, and you fill it completely up, so there's like no space. Then you put the cap on, and when you squeeze, you're going to increase the pressure, which then decreases the volume of the dropper inside, and so it goes from floating. So when you press hard enough, it drops to the bottom.
Oh, neat.
And then when you let go, it comes back up. So it's like you can kind of show them that by increasing the pressure, you're going to decrease the volume. So since there's less air, it's less buoyant, and eventually it's going to start. And it's something that's neat. So that was something that did work well. But like I said, the one in relationship to temperature and volume did not work well. So it's amazing that you have the example of one that would work, because I was looking to replace that this next year.
Yeah, and that one, it's the only thing you'll have to be careful of is when you heat the beaker, make sure your balloon's not flopping over on it, because you will melt your balloon.
Yeah,
onto it.
I was just wondering if it would melt hazard. But temperature relation to volume.
Yeah, they like the gas laws labs.
That was one of their favorites. Yeah. To increase.
And see, and this plays into our Kolbs too, because again, that's experiential learning to me.
And that's when my students do best. When I was something I really want to do this year. And I don't know if I'm totally getting off topic here, but it is still technically. I would like to do a lot more demos. So like when I introduce a topic, I want to like do a demo, and then maybe not even tell them why it's happening, and then maybe we can figure out like through the unit why it did the thing that it did. I don't know. That's something that I feel
like that idea.
I've done a better job of, because kids really like that, just like bringing the fun back into it. And I just got bogged down in everything else that is teaching, and I wasn't doing it. But I did it the first couple of units, and I even had some students comment, like, when are you going to start doing your demos? I did a flame test lab, so I got different chemicals and, made a solution with them. And then I dipped popsicles and let them soak overnight, and then we would light it on fire, and it would burn different colors of flame. And they like that one too, but it feels like it's just like a lot of setup, and you just let things get ahead of you. And
No, I agree. Like I said, I had 7 different classes to prep for.
That is crazy.
And not even one of them was the same. So I would be literally setting up for a lab and like running in between that like 5-minute, 3-minute break, whatever we have, like grabbing stuff from stockroom and trying to put on the shelves and putting things away from the other classes. Like,
Yep, it's amazing what we can do.
Heck
Okay,
yeah.
sorry. I know that
Like,
kind of got us off topic.
it's okay.
We were talking about integration in the classroom. We're talking about kind of like planning using the idea of, well, first and foremost, helping to engage students. I think that I kind of cut you off before you talk. I understand constructivism, and that's like kind of building on prior knowledge, right?
Right.
So instead of
So
like physically building, this is kind of like mentally building, I guess. That
and actually both of them are. So constructivism, you're also building on prior knowledge, but what you're using to build on there is you're building more with collaboration. It's more like a socially constructed learning. So that's with like the groups, like the discussion, and you're reflecting all together. So kind of like how this Zoom meeting's working.
so
We're
this
getting
would be
multiple
constructivism.
perspectives. Yeah.
Okay, that helps. Okay, that was. Thank you for clarifying that for me. Yeah, I feel like we do that constantly in science. I think that, I don't know, my class discussions are very hit and miss. I've had discussions that were like just like fantastic. And then you'll have discussions that just, it feels like you're pulling your teeth to try and get started.
Yes.
So I would be interested to see if there's like, I don't know, a modality of doing that.
I think the technique that I have been working really, really hard on this past year was that practice the pause, because let them struggle and kind of go through it and then and wait, and don't automatically hand them the answer. And I know it's instinctual because we want to so badly, but it's like, nope, just wait. And then eventually somebody will raise their hand and they will be like, I think it's this. And it's like, yes, now let's expand. Like,
yeah,
they're just,
that's hard.
They're just afraid to speak up, I think.
I think another one that I had used once or twice, and I just felt it was a think, pair, share, because I do think that takes kind of the individual student anxiety away, because it's not like one person raising their hand and giving an answer. It's a group that collaborated to come together, and then if it was totally wrong, at least it was 3 people that were wrong. Yeah.
Think, pair, share was a big one. So my 8th grade class, I'd say, what are they? There's 14 in there. 5 of them out of the 14 are SPED. And so we did almost everything in partners, think, pair, share. And it just seemed that worked the best for them, because even if they didn't want to talk to me, they would talk to each other.
Yeah.
And I could come around, and then they were more willing to just be out there with some of their ideas. And so that is more successful. I want to try that actually with more of my older groups, I think.
See, and I did try. I just think I was uncomfortable with it, and I got to get out of my comfort zone to figure out some of these things, because that's just not the way that I traditionally discuss. But yeah, it definitely has its benefits. I can absolutely see it. And then one of my college professors did it, and it was before every major exam. 15 of the 100 points were the TPS that you did right before, and you would just write down what you thought. You would talk to the person next to you. You'd have a couple groups share out, and then you're supposed to kind of like write down just quick notes of what people said if they were different from yours, and then he just would give you credit. Or it worked really well. It was like a good way to kind of get your brain started. Get everybody in the same mental headset.
Well, and I don't know what your lab tables look like, but I give my groups neon whiteboard markers. We have the black tables, and they just write all their ideas right there, right on the table.
Yeah.
And they love that part too, because hello, we're getting to write on the table, right?
I use that when I just, again, as one of those things, I used it once or twice, and I just felt, I don't know. Everything was such a rush last year. I just kept trying things and then dropping them. I never gave them time to really come to fruition.
Well, and then this way,
on markers, and they do love doing that.
Oh yeah.
It feels like they're getting away with something. But
even though they're doing what we want them to.
It's a good suggestion.
Well, and see, and this is good though, because this is actually Kolb's model in action. We're reflecting, right? And we're making that plan of action for the next step. Already thinking ahead for next year. So that's a good thing. Because like the one article from Kolb said, our brains are wired for experiential learning. I mean, we're not necessarily built to just read it. That's not the way our brains work. If we can see something, we can hear it, we can smell it, it's going to process it better than if you're just reading text. I mean, that's the way our brains are wired to receive sensory input. So that's all.
I think other things we were supposed to touch on was some success stories. We kind of, you were talking about that with the markers and a couple other things that you had mentioned that went really
Mhm.
well with Think, Pair, Share. Again, I feel like I probably would have more success stories if I stuck with them more, but I feel like I was just learning so many new methodologies and, you know,
Mhm.
I would try them and then I would dump them. And yeah, I
Well,
do the paper roller coaster. I was really well tied with the Kolbs because there was a lot of times they failed, and I had some groups that I didn't think they were gonna finish. I gave them quite a while. I don't know if you're familiar with the paper roller coaster design thing. It's a marble, and they act like it's a roller
mhm.
coaster. You just give them stipulations, and we did one where they had to use recycled materials, so we could just throw it all in the recycling bin when we were done. But it was really cool to watch them first and foremost be super excited about something, and then a lot of
Yes.
them just like right off the bat were like doing well. But then there were some that like built too high, and then it was very clear
Mhm.
their design wasn't going to work, and they were 2 days in, and the deadline was coming up, and it was very interesting to see, so like how they were able to work through things. And some of the students that like I really didn't expect much from were the ones
Uh-huh.
that did the best, that really came out of their shell and showed that they had that ability to have that complex thought process. And there was one of them I even said, you need to be an engineer, you need to go into our engineering program, because just everything he did, it was like very well thought out and very
Yeah.
different than how everyone else is doing it. So I don't know, it was really cool to see them be the facilitators of their own, discussions and learning. And they were going to other groups like, how did you get that to work? Like, that's
Yeah.
amazing. I have no idea how you did that. You've got to tell me. And yeah, I don't know. So I thought that was a really good success story that tied into a lot of the things that we talked about with Kolb's and the constructionism and
Oh.
just in general success in the science classroom.
Yeah. We do a foam roller coaster, but it's not anything too big. Our big project, as far as experiential stuff, I think is our Rube Goldberg machine. And I
Ooh.
tell myself every year, I'm not going to do this in class again, but every year I do it in class because it completely takes over my lab section.
Yep.
Like I've got
It's not
4
a
lab
paper roller
tables, completely
coaster.
takes it over. And so they have to come up with their own task, whatever the Rube Goldberg's going to complete, and then they have to design and engineer it. And I'm, like I said, for at least 2 weeks, it's a crazy mess in there. I've got duct tape off the ceiling. They will
Mm-hmm.
build pulley systems off my ceiling, and everything else, but it's all up to them, and they have to collaborate and they have to discuss. And then I asked them at the end, I said, okay, now reflect on what could you have done better, you know, or reflect on what worked and what didn't work in your project. And then they have to think about it and they have to tell me. And then of course we tie in all the mathematics and stuff like that with it as
Mm-hmm.
well. They have to calculate acceleration and velocity,
Yep.
all along the way, every step of their machine and so forth. So it's quite an extensive project. And actually it's a good, the first year I did it, I partnered with the math department.
Mm.
And so it was a collaborative effort between math and science, whereas they were doing the builds and they were discussing the concepts with me, and then the complex mathematics they were kind of covering in math.
That's
So that
good.
was kind of neat.
That's really good to tie in. Yeah, that's excellent. I was just thinking when you were talking about that I kind of have my students do the Coles model. I didn't realize it. Maybe not as in depth as what we do, at our level, but after their exams and their big projects, I always have a Google form that goes out, and they have to reflect on like, what could I have done? Like, how much time did I realistically spend on this project, or how much did I spend outside of class studying? What could I have done differently? And they will be very honest.
Oh yeah.
It's not the best to look through them because 90% are like, I didn't study at all. Yeah. So I guess, and then they always are like, I could have studied more. Like, okay, so maybe they're not really going through the process, but at least the guidelines are there.
Yes.
So I do for every major exam and every major project I send out. And then I'll also ask for group feedback, kind of like, was there somebody that really didn't pull their weight? Do you feel like maybe you did more than everybody else? And
Yeah.
yeah, so I guess without even realizing it, yeah, they were kind of going through that reflective process.
And I like the way they come up with ideas on how to improve upon what they've done.
Mm-hmm.
I think because they're not just forgetting about it, it's already done. Like they actually have to go back and think about, okay, well, we did this, but what can we do? Kind of thing. I like that part.
I think it would be interesting almost to do like a multi-time a multi-time project, but kind of like using what you learned from the last time. Well, now you can try, I don't know, maybe something like kind of see the improvement and have them look at their designs from one stage to another.
Oh,
of like how they've reflected on it. I don't know that they would take that as well as it's working up here, but anyway, just a thought.
yeah, definitely.
So challenges. My big challenge here, I think I've said it actually a couple times, group work issues. Behaviors-ish sometimes. Mostly it's just the one group member or two not doing the work that they're supposed to do. And when we did the paper roller coasters, I told them, if I have to remind you to be back on task, or if you're on your phone, or if you're messing with my stuff, or somewhere you're not supposed to be, it's just an immediate -5 on the project.
Right.
And that was for your whole group. So if you do it for your group, I mean, I'm sorry, but then, hold each other responsible. And I really didn't have too many problems with it. I did have some problems with one group. But in general, it's difficult. I even had them only do 2 partners because I found that any more than 2, 3 even, there's always one that just doesn't do the work, and it feels bad to have the other students put forth all the effort, and then they're just kind of riding on their coattails. So
yeah, usually I think what I found in that respect, because I did have the same issues, especially in STEAM, because STEAM was all project-based learning, so it would be mostly almost all constructionism. And what I would tell some of them is I'd be like, well, maybe they just don't know what to do. Can you maybe give them an idea? And so that seemed to help out a lot. Like if they give that person a job, usually that person will attack that job wholeheartedly. They just don't know where to begin.
yeah.
So that seems to work.
I think for a lot of the labs, it would be better to actually give them roles. Like you're the recorder, you're the this, you're the. It seemed like it was more work than it was worth when I was going through it. But I mean, now that I reflect back on it, yeah, it probably would have saved me a lot of issues. So, what about you?
Yeah.
Any challenges besides group work?
As far as being an experiential based learning, I think the challenge is just having enough time in our day to set that up for them. Not
Especially
only
with how many preps you have. That's wow.
Well, not only trying to figure out what you're going to do when you're initially lesson planning, but then trying to figure out what time frame, like, do we have enough time to do that? Well, sometimes it's not enough. Like, well, it'd be like, okay, just leave it. We'll carry on the next day, because we run out of time, or especially like we're a small school, so we don't have a lot of supplies either.
Right.
So it's like, oh, I would really love to do that lab, but I don't have that stuff. So it's just trying to still make it accessible. Like I'm not even gonna lie, I know it's bad, but the first year I ran a bacteria experiment, I did not have an incubator. We grew our bacteria in a box.
Oh boy.
A box next to the furnace. It's so bad.
That works.
And in fact, one of my students said, they're like, if this works, I'm going to go to that high price school over there, the next town over that has everything in their labs, and be like, look, what, we don't need it. Like, oh gosh. Yeah. I don't have dialysis tubing. We use eggs, for cell transport and things like that. So
it's interesting you bring that up, because I was looking at a lot of people I've been reading, they use agar cubes instead of like, the agar that you use for just like gel plating. They just like pour it into like ice cube molds, and they use that for osmosis because it does more. So I tried to use gummy bears, but the concentration of sugar in them, and I even got the sugar free, it was still too much. Like you just could not get it super saturated. But what I was reading is that those cubes, especially if you make them really small, they get massive. And so they can like really clearly see the definition there. And then you can put them back into salt water and watch it shrink again.
Ooh, I have a recipe for agar. I think I might grow one.
Yeah, they just recommend pouring it into like small ice cube trays if you can find them. And then, yeah, I think I'm going to do that for next year, because it was not like, it almost worked with the gummy bears, but just not quite enough for them to really get that connection. And also, since they're cubes, they're easier to measure, because you can get those flat edges.
Well, if you want to try it with eggs, I have the Naked Egg Lab, and
I thought about doing it. I did.
They love it though, because you can. The first 2 days is dissolving the eggshell, and then they can actually see. And what we did, and the last day, so after you put it in Caro syrup, so you put it in that hypertonic solution where it all goes out, right, and you put it back in water to have it reinflate, is we put food coloring in the water. And so when their egg reinflated, it was a colored egg.
That's cool.
So they liked doing that.
All good ideas.
So, and I did that with the 7th graders, and they just thought it was the neatest thing. All of a sudden they had green eggs,
Green eggs.
Yeah, and they're like, can we cook them and eat them? I'm like, no.
Green eggs and ham.
Yeah.
Here I am about to message myself again.
Okay.
Sorry. So, okay, challenges.
So, but availability of materials is definitely a
Yep.
challenge to present that creative learning
And
experience.
then probably space too, especially if you're, and you have 7 preps and you've got to put their things somewhere. I'm pretty fortunate. We have this like back hallway that no one uses because it doesn't go anywhere that anybody goes. So I usually kind of just shove our stuff out there, but our custodians don't love it when I do that either. So I'm extra nice to them during project season.
Yes, our cardboard boats take up all the room. So Rube Goldberg's and cardboard boats are the two that take up the entire space we have. And STEAM just seems to take up the entire classroom. I mean, I have a request into my husband to build a cabinet, especially for STEAM.
Yeah.
Mm-hmm.
Well,
otherwise, I don't know what else. Let's see. What else? So, one of the ones, what I want to try to use the Kolb's reflection model for experiential learning is our pond lab. We do a 3-day pond lab out there, and the kids spend 3 days. They incorporate everything they have learned in the lesson into this one lab. But I would really like to try to implement that reflective process and maybe back off on telling them what they need to see and maybe just see what they come up with. So just so they can do more of that experience, or do you think that would qualify if I say, okay, build a food web and then have them find things in the environment to build their food web? Would that still count as experiential learning?
Absolutely. Especially because you're not giving them that basis. When we went over food webs, I definitely gave them pretty much all the information. And it was one of the tests they did the best on, but I feel like it's because we really hit it and it felt, I think, relevant for them, just being able to like really see that. And I was very lucky. One of the old, really like several decades ago, I want to say like 40, 50 years ago, one of the teachers there made a giant food web, like the size of the hallway. And it had rodent and like bird bones and like a whole bunch of other sets of bones. And it was like huge. And there was probably like 40, 50 organisms on it.
Wow.
Really cool. So we were able to like, I had them all kind of set that up, which was really cool for like collaboration. But yeah, we mostly gave them everything. So I think that, yeah, the way that you're defining it, I think would be absolutely an example.
So I would definitely want to try to draw that more in, because I think, again, like we said, science, it is all hands-on. I don't think if you walk into a sterile science classroom, I don't feel like you're doing science.
Right.
It has to have something, at least I don't think I would have learned it very well that way. Yeah, even if it's all on virtual, I still don't think I would have learned it quite as well.
Yep, agreed.
And just because we have kids that have that modality, so they have to touch and they have to see. You know, not everyone's logic based right off the bat.
Right. Especially not off the bat.
No. I can't see that happening. And then two, I mean, I feel like at the same time as they're experiencing it, they're pulling in that schema, right? So they have what they already know. They have a preconceived notion of it, and then they're able to build upon it and apply that new knowledge to what they already know. That expands their old knowledge. So I think it always puts me in the mind like photosynthesis, right? So like photosynthesis, elementary school, what do we tell them? Sun, plants make food from sun, right? Junior high, we give them the chemical formula. Okay, this is actually the chemical formula where now plants make food from the sun. And then in high school, when I get them in bio 1, now I'm like, okay, well, guess what? Oxygen is now the electron receptor, and this is doing this, and this is the light and dark reaction. And they're like, oh my gosh. But at least they have that
prior knowledge.
Yes, the prior knowledge to build upon. And I think if we didn't do that, we would overwhelm them.
Oh, yeah.
So we definitely
that's a really good example. Same thing with like cellular respiration, although that's, yeah, I think that for everybody, that's difficult.
Yes. Or mitosis and meiosis, right? You teach mitosis first because meiosis is essentially mitosis twice.
Right.
That's what I tell them. So we hammer them hard in mitosis. Yeah. So, I mean, I feel like, honestly, I feel like all these learning theories, I feel like they're very independent or interdependent on each other. I don't think they really function by themselves. So,
sorry.
No problem.
Yeah, no, I think they're all, and then I also think this about a lot of curriculum and things like that. So like when we think about the storylining that I was talking about and modeling, and these are all so closely tied together, and constructionism and constructivism, I feel like they're all almost talking about each other. So yeah, they're all very, very closely tied in, and with the scientific theory too. So
yeah, I don't think any of them are drastically different from one another. So, at least from my learning standpoint, from looking at them, everything involves collaboration. Everything involves building on prior knowledge. Everything is going to involve reflecting on what you've done and making a plan to make it better. So I don't think, like I said, there's no bubble, right? It's just all interdependent on each other. And I think the challenge then is for us is finding ways to incorporate all of that and try to get the best way to present that knowledge for our kids, like, and just keep our fingers crossed and hope that we can get it to them and hope they can understand it. And then if not, what do we need to change?
Reflect on it.
Yeah, reflect and change. I feel like that's the bulk of what I do.
Yes, absolutely.
So.
All right.